Okay, good afternoon. So I hope you have enough time to rest in the reading week. So we're gonna start up today by, I believe in the last week I sent some announcement on the Moodle. So please make sure you have a valid email address registered at your profile. So we graded the multiple choice and you can see the feedback. And the feedback is designed in such a case you can see your response to each multiple choice, and then you can see correct, incorrect, and each multiple choice questions worth 2 marks. Now, we have also short answers during the lab test 1, and the short answer, you see the response from you, and there was something like you put some code at quotations, semicolon. I don't need that. You can put the quotations directly. So it would take too much time because most of the students didn't follow the instructions. When I graded them, I was going to the direction of give you 0 because you didn't follow the instructions. It's clearly saying put the type, put the value. And whenever you have a string type, string start with S as a capital, okay? And then comma, you have to put double quotes. That is how the string value in Java. Without double quotes, the value you send it, it's not a string value. And without a string as a string S as a capital, is not a data type is recognized by Java. But I was lenient too. I give half a grade for a student who is just answering string and even the double quotation is missing. But next labs, lab test 2, lab test 2, 3, I will not be that much lenient. I will be so much restrict. I understand this is maybe your first time working with Java, this is first time lab test. So that's why I was lenient in giving the grade, especially for the short answers. And regarding the programming, it's another nightmare to grade it for 220 students. It was really painful going through your response, not compiling, nothing is working. Some students, they copy the questions, they put it on the response. I don't know what they are gaining from that. So we would like to see code that is compiled, and that is really solve the problem that we ask you to do, okay? So please take this notation or these notes and try to make sure your answer to the lab test 2 more accurate and follow the instruction of the questions. We did demo lab tests before the lab test 1, hoping all the fear that you have, it's gone. You go to the lab test 1, you're supposed to be relaxed for 2 hours. I used to give 1 hour, 20 minutes, but I give 2 hours. So you should read the question carefully, answer the questions. Shortly, I will announce in the Moodle, I will put the questions with the solutions. So you have your own feedbacks, you have the solutions. Whenever you have a problem, you can approach me in the office hour or send an email to me, I can reply to you. Okay, let us start with lecture number 6. So, last time we covered Java controls, selections, and repetitions, comparing data types. We emphasize on comparing data type. We said that whenever we come across primitive data type, we can use equal. But whenever we come as an object data type, a class that we are creating like a string, Java expert to create this class for us, we cannot use equal. What we should use to compare for quality, what we should use? Dot equals. We use dot equals is a method that allows us to compare the content of the string, because whenever you are comparing object data type, with equal equal, you are comparing if they are referring to the same positions in the memory. And also we discussed generating random numbers, and we touched the topic of exception. We didn't complete it. Today we're gonna talk about exceptions, array, and if we have a chance, we're gonna go to the string. Now, just to highlight this example from the textbook to determine if the input is positive and even integers. So we use if statement. As you can see, the implementations, the objective of this is to highlight how a student can approach the problem. So the question is asking if the input integer is positive and even. So you can see we define a Boolean result is equal to false, and we ask if x is greater than 0, and we have the braces open and close for if statement because we are having more than one statement. So we are opening the block and close it with the braces, and then we ask if x divided by 2, the remainder of it, the remainder of the division, that's why the percentage here. The percentage is asking if the remainder of the dividing by 2 is equal to 0. We are able to use equal because we are comparing a primitive data type, which is an integer. Then we're going to set the result to true. Otherwise, the result will stay unchanged as false. You see, if the x was negative, then we're not going to go through this if statement. We're going to go directly to retain result, and result in that case will be equal to false. Now, if x was positive, then we're going to go inside the if statement, and in this case the if statement, there is another if statement inside it which is ask if x remainder divided by 2 is equal to 0, then we're going to set the result to true, and we're going to get out and retain the result. Any questions about this implementation? Yes? String? What is the No, you have to change the method. Because Boolean status is a primitive data type. String is an object data type. So you have to change the header, you have to change all the details inside the methods. So whenever you change the data type is retained, you have to change everything. So you have to define a new string and you have to retain a string. You cannot define here I retain a string, then I retain Boolean as a data type. If you do the necessary changes, do whatever you like. You can print a string to the user. The input is positive and even. Everything, guys, is not about if I change. It's about the questions. The question is saying you receive integers and you determine if this integer is positive or negative, and we have to retain Boolean true or false if the integer is positive. Now if I ask you differently, I ask you print a message, okay? If the integer is, you have to print a message, okay? You have to use printing message, okay? Now, you see here we define result, we check the big if statements, then inside it there is a nested if statement, another if statement, and we set and then we retain. Another way to implement it, it's not a fixed way. So if 2 or 3 students at the exam send the same implementation, you start wondering how they got it, okay? Now, you can re-implement the previous questions differently. You can combine the 2 conditions together with AND operations. As you can see here, the AND operations is used to combine 2 conditions at the same time. So if x is greater than 0 and x is even, we're going to go inside. Otherwise, we're not going to go inside the if statement. So you see here how the power of and or not to combine the conditions together to build more robust if statements. Another way to implement it, you don't need this messy if statements. You can have this statement. It's a Boolean statement. is a statement with the retain type as a Boolean. You see the left-hand side is evaluated, x is greater than 0 and x even equal to 0. Then this will be evaluated as a Boolean expression, and it will return true or false if this is a true and this is a true. So if both of these are true, or return true. So it's one line in this slide. If you count how many lines here, 1, 2, 3, 4 lines, maybe here more than 4 lines. So the same method is implemented differently. Now, it's come to the questions, when you are as a programmer, okay, you have all the tools. All of us have access to the same tool of Java programming. If statement, for loop, while loop, else statements, whatever you have as a data types, primitive data types, all the tools are available for all of us. Is how we are implemented is built based on you. Because each one of us will implement the same method differently. Okay? This is another example on the textbook, which is retain the largest factorial of a given positive number. You're trying to factorize the numbers and retain the largest factors of that number. You can see the declaration of the problem, the declaration of the method, public static int, largest factorial, and int as an argument. So you receive an integer and you retain an integer. Receive int, retain int. And the method is a static method. You see the result is equal to 1. The most largest factorial we start with is equal to 1. And we start doing for loops. The for loop, int I is equal to 2. We start from 2. I is less than n. And we increment n each time. And then we ask if n divided, the remainder of dividing by I is equal to 0, that means this is a factorial. Whenever you have, let's say, I give you integer 9. I told you 2 is a factorial, a factor of 9. You say, no, 9 divided by 2 is equal to 4.5. There is a remainder, and remainder is not equal to 0. Then 2 is not a factor of 9. But if I give you 9, I give you 3. 3 is a factor of 9. How I test that? I say 9 divided by 3 is equal to 0. Yes. The remainder is equal to 0. You check if the integer is a factor of another integers by checking the remainder of the divisions. 15, the factors of 15 is a 3 and 5. 2 is not a factor of 15. Why? Because when you have 15 divided by 2, you have 7.5. 0.5 is the remainder, so that's why we are excluding 2. This is a procedure that you check it with use pencil and paper. You translate it here on this method. Rather than checking all the factorial, how you're going to do? You're going to go from 2, 1, everybody agree that 1 is a factorial of any number, because take the number, multiply it by 1 is the same. Take the number divided by 1, you'll have always remainder as 0. That's why we have result is equal to 1. Now we start from 2. We check all the integers from 2 up to n. Of course, n is a factorial of n. Factor of n, because n divided by n is equal to 1. The remainder is equal to 0. So n is a factor of n, 1 is a factor of n. So that's why we checking all from 2 up to n minus 1. And what we do, the same process in the mathematics, we translate it from the programming. We use the tool of percentage to check the remainders. We take n, the remainder of the division. If it's equal to 0, then I is a factor. We store it in the I. We keep doing it. The largest factorial will end up with result, and we return it back. Any questions about this? What is the objective of this example? Is to see that the computational thinking that you have, the problem that you face on the mathematics, to do it in pencil and paper, you can translate it to the programming. Yes?
In this example, how do you make sure that you return the largest factor?
Let's say you have 7 trace the execution for 7. What is the factor of 7? 1 on 7. So we start with result is equal to 1. And we keep checking all the integers from 2 up to 6. Yes? Then there's none of them. So we retain 1. 1 is the largest. Good? So that is the case where you have to make sure that the mathematical computation is matched to your implementation. Here we have to check by testing the algorithm. We're going to come across to the topic of JUnit test, okay, where you create a unit test to test your algorithms later on in the course. But how I prove that I'm retaining the largest one? I did the implementations that match with the mathematical. I'm sure that my implementation is correct. How I'm going to assure my implementation is correct? By running test unit to these algorithms, to this implementation, I mean. Now, I can trace the execution, let's say, for 15. Okay? For n is equal to 15, I'm going to start with result is equal to 1. I'm going to count 2 is not a factorial, 3 is a fact. So I'm going to store it on result. Is that right? Then I'm going to continue. 4, no. 5, then I will stop at 5. There is no factor than 3 and 5. So I will retain 5. So the implementation the problem that we face on the mathematical, we translate it to the programming. That is the main also objective of this course. So whenever you have questions, it's a represented problem, you try to come up with the tools. Try to use if statement, for loops, define the variables that can help you to solve this problem. Okay? Any other question? Okay. This is another example about log2, how to calculate log2. And this is another implementation, one using for loop, another one using while loop. I leave it for you to take it, build it using Android Studio, and run it and test the implementation if it's calculated or not. As you can see, we change the tools, we change the implementations. We have now experience with if statement, we are experienced with for loops, how we create a for loops, then we change the way of implementation. It happened that on the lab test 2, that will be on November 8, I will ask you directly, implement this using for loop. So if you give me an implementation using do while loop, it will be rejected, will receive 0. I will ask you use if else statement or use switch statement to implement this method. So if you are using any different tools than that I ask you to do, then you receive 0. There's no point of lenience or something like that. So you can see here the same method is implemented with different tools. So you need to be strong enough to use the while loop. Don't afraid of while loop. So I'm afraid of while loop. I never do it correctly. So always use for loop. No, using only one tool is not enough. I need you to be able to use any tools. If statements, switch statements, if else statements, you nested if statement, for loop, nested for loops, while loops, do while loops, all of these you need to master them and do the implementation. You need to be easily switch between while and for loop or between for loop or while loop. I will give you the implementation on for loop. I will tell you, okay, give me the implementation using do while loop or give me the implementation using while loop. There's a lot of variety of the questions, but all of them is related to how much you are strong of using the tools. All of us have access to the same tools and we implement the function differently. Now back to the main topic about exceptions. We discussed last time about it's never possible to predict what is actually going on in your programs. And sometimes you will have unexpected error that's make you disappointed why this app is not running. But we have a tools on Java to catch this error and try to handle this error before it's received by the user who are using your app. So the exception is a very important instrument that signal something abnormal to the Java, inside the Java. So Java use this exception to signal something that is abnormal. And exception normally describe an error that is caused by your implementations. You try to divide by 0, for examples, or you try to access some space or some variable that is not defined right now. So some of these error or some of these exceptions, the compiler try to catch it for you. That's why we call it a checking exceptions that or checking errors or error already checked by the compiler will not allow you to compile your code without fixing this problem. But there's sometimes an error that already occur at runtime, and also there's sometimes an error that related to external issues that are outside of your program, like you're running the app out of memory on the device, so you will receive an error. So you have to keep in your mind every public method should verify all the required preconditions before doing any computation. So if you say that I'm gonna receive for this method, I'm receiving only a positive integer, and once I have positive integer, I'm do the computation. So you have to make sure that you receive a positive integer. Otherwise, you will run with some unexpected exceptions are rising up. We're saying always that the precondition is a responsibility for the client who are using your app. But you as a developer, you have to avoid doing a wrong computation and retaining a wrong result to the user. You might have to raise an appropriate exception to the user saying that, okay, I expect to receive a positive integer and you're entering a negative integer, or you're retaining enter the double in value, or you retain a string rather than entering the integer value. So you have to be able to detect these abnormal in your or any violation for a preconditions. Now, exception, they might be terminate your program if you didn't handle them very well. So sometimes we can recover from these exceptions by catch them these exceptions and recover them and continue the executions. Now, this is the hierarchy. It's very sophisticated hierarchy on the Java. They start with the objects, and there is a throwable objects that extend this object. Inheritance is not the topic of this course. That's why we just saying extend. So you can say this is the parent, this is the child, and this is the child of this is a child of throwables. So now throwable is an object, and there is an exception, and there is an errors as a child for throwables. And these are the error. The system error are thrown by the Java virtual machines. So whenever you are coming to this side, it's no way you can recover. If your exception was categorized as an error, then a system error, you cannot recover from this one. Now, if you are in the other side, which is the exception side, this is describe an error caused by your program or external circumstances. And you can see there is a lot of category here. They have a class not found exception. You try to define an object of a class that is not exist, for example. There is an IO exception. The naming is meaningful, okay? And you have a runtime exception that is occur at runtime, and there is another subchild of runtime exceptions too. So this is a runtime exception is caused by a program during the execution. So during the execution, it's called runtime exception. So during the execution of your app or the program of your app, we have this execution. Trying to do bad arithmetic exceptions, try to access the object that exists but is referring to the null pointers, and index out of bound exception. We're going to see this when you define the array and you try to access an element that is not exist on the array. And also illegal argument exceptions, and there is several other exceptions. So this is a complete hierarchy of the exception on the Java. Runtime exception is unchecked exception. You have to keep that in your mind. So you cannot check the runtime exception. Say, okay, I will check the runtime exception before the runtime. It's confusing because it's runtime exception. It's happened at the runtime. And there is these are the famous three exceptions. We're going to go through them. Is arithmetic exception when you try to do arithmetic operations that invalid, and also null pointer exceptions, and index out of bound exception. What you can do is trying your best to avoid have these exceptions at the runtime. Try all the effort that you do all the arithmetic correctly. Try always to access objects that are referring to another object or referring to an object in the memory, not referring to null objects. Okay? Yeah, you try to prevent these from happening in the first time. That's the only way to avoid. What is the null pointer exception? Is through if you are accessing an object or through a reference before the object is creating. You have the reference to the object, but you're not creating the object itself using a new keyword. You create the object's reference for the object, but you didn't use a new keyword to create the object itself. So you have a reference pointing to the null pointers. Index out of bound will try to access an element inside the array that is not exist. We're going to come over this in this lecture. Some fact about the exception: when the error is detected, you have to exception is thrown. Now, the exception is thrown. That means we're going to go to the exception handlers. If the programmer did not provide a handler, okay, that will catch this exception, the default exception handler may terminate your applications. Now, the exception can be rethrown. You can catch it and rethrow it again. Okay. Now, there is a 5 keyword that always come with the exception handling: try, catch, finally, throw, throws. So all these 5 keywords related to the exception. You try some statement, you catch an exception. Then once the exception handler is finished, you go to the final, always finally is executed. Then if you want to throw the exception again, or throws the exception. This is an example where you have some statement. You try some statement here. This block, always try. You open the braces, close the braces, and you have some statement. These statement might throw the exceptions. You try to catch exception of type 1 at the first statement here. You try to catch exception 1, and then you handle exception 1. If the exception was raised on this statement was of type exception 2, you go to the exception 2 handle. And you can have a big list of catch. As you can see, you have one try block, and you have many exception handlers based on the type of the exception. If the exception was arithmetic exception, I'm going to do this. If the exception was null pointer exception, I'm going to do this. So whenever is different type, you can see you have 1, 2, up to n catch exception. So you can have many catch, but you have only one try. Okay? You can have nested try and catch if you would like. Now, you can see here, we try some code. We catch file not found exception. So this is the first type. So if we have file not found exception, we're going to do some code here. We cannot do all of them because we have only one exception raised, and we can handle that exception. We cannot catch all of them. We're going to go to one of them, okay, based on the exception. And you can see we are from specific to generic. Exception is more generic type. So whatever is the exception is there, I'm going to go there. But before the generic type, we have more specific input-output exception. So if this exception was raised on the try part related to the input-output, we're going to go here. We're not going to visit exception on this side. Then after we finish here, we're going to go to finally. So this code always execute. So the finally always execute on that try, catch, finally of place. Any question? Yes?
So in the try part, so let's say 100 lines of code and catch file not found exception of X was caused by line 2.
Yes, stop execution at line 2. We go directly to this.
Okay, so it doesn't go for 100.
No. We stop. We stop execution if the line number 2 raise an exception in 100 line 2 raise an exception of file not found. We go to the catch bar. Is there a specific catch for find not found? Oh, yes. We're going to run this execution. And after this one, where are we going to go? Where are we going to go? No. No. Final. Okay? Now, during the 100 code, we have exception of index found not found. We go to the catch. Oh, this is find not found. This is not my exception. I input output. This is not my exception. Then I'm going to go to the more generic exception. I'm going to do the code here. Then what should I go down? Finally. Always finally execute. Keep that in your mind. And we stop executing at the point where is the exception is raised. So it's a 100 line code. At 99, we stop execution. The statement number 100 not executed. Okay, so this is a try, catch for more specific, then another specific, input, output, and this is a generic. This is how. It's not, I'm not sure, but I think the compiler will try to check it for you. If you try to make a generic beginning and specific at the end, you always go to the generic, because the execution will be in sequence. If input, output, then IO, then generic. Okay? If you put the generic first, then you're going to go to the generic always, even if you have input, output at the end, but always going to see the generic. And finally, always will be executed. A good place to clean up if you have some resources you need to clean it up. Yes? No. You are expecting. No, the only way to check if what type of exception is catching a generic one and then dig in deep and see what type of exception by printing the message or something like that. But on the catch bar, you write a code that can read and from the file. You expect that find not found exception. That's why you try to handle it. You understand me? You cannot know the type of the exception when it's raised. You can expect what the type of it. And that's why you put some catch what? I think there will be something like that on the message, okay? You try to see it, but I'm not going to go deep on the answer on this to see where is, because whenever you have an exception, we know where we are executing in the program. We might have an idea where is that exception is. Any other question? Okay. So this is an example where you throw the exception. You are asking to withdraw some amount from your bank account. So if the amount was less than or equal to 0, nobody, if someone tried to draw money with negative amount, okay, minus $10, so then we're gonna throw a new, you can see the syntax, throw a new, a runtime exception, we cannot throw a negative amount, okay? And also if you are trying to take a money from your bank account that is exceed the balance amount, you throw another exception, throw a new runtime exception, you give the not enough cash. Okay, you can see now how you can build this in your applications, in your apps. When you develop the app, you throw an exception and you toss a message to the user, you enter invalid month, you enter invalid years, so you make sure that everything is in the proper way. Otherwise, if nothing is happening, we're going to go where? To the deducting the money from the bank account. This is another example. I would like you to look at it for a half minute and let me know what is the result. It traces the execution. We have the method, okay? Similar things will be on the lab test too. So I give you the fragment where the exception is there, try and catch, and I ask you what is the result, okay? What this will print to the user if we try to run it. Yes. And I am in the final block. So because finally always will be executed, that's keeping in our mind that always finally will be executed. So I know that this message will be printed. Okay? But now when it will be printed, where is the positions? What is the other? I'm going to check the arithmetic exception. I have A divided by P minus C, and we have the parentheses around P minus C, so we're going to execute that first. So 5 minus 5, that will end with 0, and we end up with 10 divided by 0, and that is arithmetic exception. Do we have arithmetic exception to catch? Yes, we have a catch block, arithmetic exception. Then we have this exception catch by dividing by 0. And then, where are we going to go? We're going to go to the final. I already mentioned what the point of it. It's a cleaning up. Sometimes you build the connections to database, you create a file, you need to close the file before you exit, okay? Otherwise, you're leaving the file open or the connection is open, it's a problem, okay? So always the finally part is very important for a developer to clean up. You delete some object that you create, okay? Or you disconnect any connection to database or connection to the websites, okay? Imagine you develop an app for a bank, okay? And you log in using username and password for you, and there is an exception happen. Then you need to go to the final part, for example, and do disconnect and do a cleanup, so this connection will not stay on, okay? So the same thing, you open a file, you write some information on the file, and there's an exception happen. You need to make sure in the final part you close the file. Because next time when you run the app, you try to access the file will stay open. You have to turn off the phone off and on to make it on working. Okay? Because this is again very important for multi-threading programming. So threads are communicating with the same resources, and one of the threads raises an exception. You need to make sure this connection is disconnected so other can use this file. Okay? Finally, has a lot of useful use to it. So depend on your application or apps that you are building it. Okay? Good. Now we start an array. I would like to ask you questions. How many of you are familiar with array? 2. You take a prerequisite, so you're supposed to be. I assume all of you are familiar with what the array is. But even that, I have this slides and also the textbook is more comprehensive about how we can define an array, how we can work with an array with Java. It's very important to keep in your mind before we start on, a primitive data type aside, an array is a data type. It's another data type. Okay? Array, it's come close to an object's data type. Okay? Now, what is the beauty of array? It's like you have to define 10 integers all together, and you need to access them, okay? Then you say, okay, I will put them on array. Array of all the data types are the same. So you try to make them all sort. You go to your room or your desk, you have all the books that related to the current semester, and these books related to the previous semesters. So you try to stack them all together on the top of each other, so you can easily access them. You don't lay them all on the disk. So you try to put things organized. The same idea, we have it on the programming. We try to organize things together. So more than a primitive type, less than the object. So you can think about an array is not a primitive type for sure, but it has a lot of features like an object. Okay, so it's like an object when you are using it in the method parameter or return parameter because you are referring to it as a reference, and do not have inheritance, and inheritance is not part of this course, so you cannot extend an array of an array. So that's why it's not an object. Okay. Now, it's very good to use because you put all the elements next to each other, stack them all together, so you use for loop to access the elements all together. How we can create an array? You can create the array with this syntax. You have the base type, then brackets, array name, give a name that you like based on the identifier style, then equal, you see the new, that's another similarity with an object, because whenever you need to create an object, you have to use a new keyword. So we have a new. We're going to return back to the base type, the one that you start with at the left side, and between the brackets, you give the length. You have to fix the length. So when you define the array like this, the length will be defined. And you cannot change the length of an array unless by destroying it and create a new one. Okay, this is an example. I want 80 elements of an array with the base type char, which is a character. You see, I follow the syntax. I would like you to master it because it's really painful to lose a marks by not able to define an array. It's very easy. Char, a brackets, empty brackets, symbols, the name that you choose, as long as you are following the identifier styles, equal new, and the base type again, char, characters. And you give a number 80. So this is a statement here, define 80 elements with the base type of characters. I need 100 element of type doubles. But whenever I want to 100, I don't need to define 100 variables. So I define an array to store all these 100 all next to each other so I can easily access them using one name. So I define doubles, brackets, into brackets, reading equal new double, the type that I need, and I put the brackets 100 element. Don't forget the semicolon. Yes? Yes, it will always pointing to these 100 elements. Not the first one. You have to put brackets. We're going to come across how we can access the array next slides. Now, a species is an object. Now I need 70 elements of a species. A species is an object, okay? So we create a species, brackets, give a name, specimen, and a new species, and we give 70 as well. So you can create an array of any type, a primitive data type or an object type, okay? There's no limitations. But what is the limitation here? Can anyone remind me? We already discussed this in the previous slide. What is the limitation for the array? We cannot change the length. Any other thing? I can change the content, no problem. All the elements inside the array should have the same data type. So you can see doubles, all the elements are doubles. Int, all the elements are int. Species, all the elements are species. If I need another, I cannot, like I use this array to store double, then I decide to send a string. That's a problem, syntax problems, okay? Good. So data type array, this style is allowed, but not preferable. So you can define an array by putting the square brackets these after the name. This style is acceptable by Java, but is not preferable. Okay? So keep this in your mind. This style is not preferable, even if it's acceptable. We're gonna follow, in this course, we follow this style. Base data type, then we have the brackets, array name, then a new, and also the base type. Now, if I define 10 element of doubles, how they are look like? So we have my list, as you can see. equal a new double 10 elements inside the brackets square, semicolon. So my list will be a reference, as your questions is not referring to the first element. To be able to retrieve the first element, you have to say my list, and you open the square bracket and you give 0. You can think about it, it's just a label. You label all these 10 elements by my list, and you use this as a reference to access them. To be able to access the element number 5, you have to say my list, and you open the square bracket and you give 5, you access. What is you see here on this slide, that you define 10 elements, and the index actually is a start from 0. The index is not starting from 1. So if you ask my list.length, it will retain 10, because you define 10 elements. If you would like to access element number 10, you will have an exception, because element 10 is not available. Okay? The only element that you have is from 0 up to 9, which is length minus 1. So keep that in your mind. Java is using 0 as a starting point for an array. So the first element of array is element number 0, and the last element of array is a length minus 1. Now, the bracket is very important to access the array. So if I use int with a bracket, this is not a data type. A primitive data type is integer. This is an array of integers, okay? So this is a new type. You can think about it is an array type. As I mentioned, it's not a primitive, but is most likely like an object. Now, int with a square bracket, this is an array, and int by itself, this is a primitive data type, represent a value. To create a new array, you have to use a new keyword. So I can use int and define the name, then I have to use a new one. By defining int with the square brackets and give a name is not enough. I didn't create an object. I didn't create an array object. So I have to use a new int with the same type and give 100. Now, to be able to access the element, we can access the element using the square bracket and give the index of the element. So this slide, somehow it's give a summarize of the terminology. So the array name is temperature, n plus 2. This is the index, okay, for the array. And also you have temperature n plus 1, which is accessing the element, okay, next. And if you need to change the value of any element, you give the array, you give the square brackets, and you put the index equal, you give the value. So the value, this is the value 32 will be stored at the element n plus 2. Now n plus 2, this is very important. You can have arithmetic expression that retain int inside these square brackets. So I can have 2 times n plus y minus z. As long as the retain type is int, I can have it here on the expression. So you can see here n is variable. I don't know the value of it right now. So whenever I evaluate run the program, I know the value of n. I plug it here and I add 2, then I go to that index. Array length, we discussed that whenever we are defining the array, we have used a new keyword, and this storage will be allocated for us. Now, the attribute length, as you can see, we define a species entries and a new species 20. So you can ask entry.length. And we cannot change the length of this array by any method. We can only by destroying the array and building a new array. We need to give a length because we need to define the size. If you don't need to give the size, then you don't need to use the array, you use the collections or the collectors, which would be on the next chapters, chapter number 5. So that is the dynamic. You extend, you shrink, you add whenever you need. I don't know right now the actual length of my array. I define array list, okay? Or I define a hash map or something like that, a set. I don't know the length, but whenever you come across the array, you have to give the length. You have to give the length. So the length attribute is established in the declaration type. This is the answer for your questions. So at declaration type, you have to give the length, and you cannot change it, okay? You can change it by redeclaring the array again, by destroying the current one and building another one. So the subscript always we build by 0 and end with n-1. We discussed this. So you start the first element by subscript 0, and the last element is length -1. So this is an example for an array of 4 elements that start with 0 and end with 3. Subscript out of range, always if you try, the Java give you this opportunity. Other languages, they don't have this, like C++ or C. They allow you to access the next memory, but Java will prevent you from accessing any element that is array out of bound. And this will raise an exception called array out of bound exception. It's very meaningful that to let you know that this is you trying to access an element that does not exist, and this is happen only at runtime. So this exception, you can see this exception not at the compile time, at runtime. So array of a specific length at runtime, this is also, you can define it, but is another way, but is not a dynamic. I cannot say a new int with an empty something here. That's impossible. So I can know the size while I'm executing the program. I know the size. Then I can define a new int with size. It's another workaround, but is not dynamic as array list or a hash map or hash set. Okay? Any question up to this point? Okay. So using, that's a name terminology. So whenever you come to define an array of objects, as you can see, a score of 3, element 3, is easier than scores at 3. Okay? So it's good to use a singular rather than plural names when you define the arrays. Okay? It's more easy to read and more informative. So when you are defining an array, avoid using a plural names to a name as an array. Now, initializing the array at its declarations is another opportunity where you can define the array and initialize the value at the declaration time. As you can see here, I create double, I open the square bracket and close them, then I give a name and equal, then there's a braces here, and I give the value, 1, 2, 3. So I give 5.1, 3.02, and 9.65. These are the 3 elements. The Java will compile the code and understand you're defining an array of 3 elements, and also will assign the value for these 3 elements. So the 3 elements will have element number 0, 5.1, and element 2 will be 9.65. Now, to access the element of the array, we see the power of for loops. For loop is very powerful tools to access the array. As you can see here, we define an array or name A as an int, and we can access all the element and assign 0 to them. You can see the for loop. We start from I is equal to 0 up to I, a dot length. A dot length, and you can see as long as I less than a dot length. What is a dot length in this case? 10. So it's 10 when I is equal to 10. Then the question will be raised. 10 is less than 10. A dot length is equal to what? 10. All of us agree about that. So, and the element of A will start from 0 up to 9. So there is no element number 10. So that, remember this, 10 less than 10, that's false. 10 is equal to 10. So we're going to exit the loop immediately. See here, AI less than a dot length. Some students have implemented similar things with I less than or equal to a dot length minus 1. Do you think the implementation will be complete? Why? Because they missed the last one. In case if you want to use a dot length minus 1, you have to make I less than or equal. Okay? So you have to make sure that you understand a dot length correctly, because a dot length will retain the number of element in your array, and in this case is 10, and the index of elements start from 0 end by 9. So always keep that in your mind. So do not count on default values for the arrays elements. This is very important. Oh, I know Java will take the default values. Don't count on that. As a programmer, might be is not related to this course, or maybe you're not going to have a questions on the test for it, but keep that in your mind. If you are working with Java or whatever is the programming language you are working with, do not rely on an initializing of a default value for the array. Always, if you want to initialize the value by 0, do it. By -1, do it. Whatever is the initial value or default value, do it. You want to create an object, a class, and you need to construct an object. Make sure the constructor construct the object with the appropriate default values. You as a programmer agree about it. You and the client agree about this default value. Okay? In this thing, okay, I will leave you here. What do you think about this slide? Is there any problem? I tell you, this is wrong. You cannot mix it up. That's the point in this slide. If you would like to have it like this, you can initialize it in the first line, but you cannot mix it up. Okay? For example, this case, you cannot split things together. If you would like, I can give this one here. Okay? I cannot split up. So keep that in your mind. Okay? There's two ways to create an array and initialize the value. Either use a new keyword, give how many elements I need, or I give the initial value between the braces, and then I know the number of elements. So this is another program. We're going to trace it quickly. So you can see here what is I think already this slide with you, so you know how to the result here. We have defined array of 5 elements, and we're going to go for loop for all of them. I know this is not a good practice, by the way, putting 5 here. It should be values.length, okay? And then we start looking for the elements. So we start by element I, then access I minus 1, and then we store the value at I. So we start with I is equal to 1. So we look at the I is equal to 1. And then we look at the values at index 1 and value at index 0 and add them together and store at 1. You can see this, we define an array of 5 elements. I is equal to 1. This I, we ask the questions. I is equal to 1 less than 5. That's true. Then we go to the element number 1. We're going to have I plus, what is the value? Then after this line is executed, the I will become 1. Why? I don't know. Yes, always zeros, I think. Yeah. Unless if the I minus, yeah, I think we should revise it. I think that this is supposed to be 1 to be able to work. Yeah. No, value is initialized to 1, yeah. Okay, I plus 1. Yes, is that above? I think this is supposed to be I, not this value is I. Because this is 2 plus 1, that's 3. And this is 3 plus 3, that's 6. This value, it should be I. Okay? And this is the last one. Okay. So we check this example later on, I will revise it for you. So if you send an array as an argument in the method, as you can see, I ask to have a method here, public static void show array, and you can see I cannot say I need to send an array of characters, so I define char with square bracket a. So in this method, I receive array as an argument. This is how you send an array to a method to work on that array. Then I come inside the array, I start printing the array. So you can see here I define a grade, and then I say my classes dot show array, and I send the grades. Now there's nothing different in the call sentence, but in the header of the parameters here, we have to make sure we are receiving an array. Now, to copy the array, it's sometimes the students think that if I use equal sign, it will do the task for me. And you can see here we have array list 1 and list 2. Both are different. And this before executing this statement is you have a list 1, list 2, the content of the list 1 and content of list 2. So before executing, this is before executing the statement list 2 is equal to list 1. So statement list 2 is equal to list 1 is not doing the copy of the array, because the array is a reference whereas the element are stored on the memory. So whenever you execute the statement list 2 is equal to list 1, you simply making list 2 pointing to the same content of list 1. And what happened to the content of list 2? They're going to the garbage. No one can access them anymore. Okay, so you have to make sure that is clear in your mind that whenever you are trying to copy the array, avoid using equal sign, assignment statement. This is assignment statement will end up making two references pointing to the same array, as you can see. Any question? Oh, that's depend on the mechanism of the Java. The garbage collectors will execute periodically to send all unreferenced objects to clean them from the memory. So you will not run out of memory. Okay, now using equal with an array name, they are reference of a types. So here you can see on this examples, another example to show the point, we define A and P as a int arrays. The first one with 3 elements, the second one with 3 elements. And you can see here, the for loop try to initialize the element of array A to I. So the element of array I after this for loop will contains what? Can anyone help me here? After executing this for loop, what's the element of array I? There are 3 elements. What's the content? 0, 1, 2. 0, 1, 2. And now we execute this statement saying P is equal to A. Now what is the effect of this execution of this statement? Is making P pointing to the same A. We're not copying A and assign it to P. We make a new copy of A. No, we have now 3 elements of type integers, and we can access these 3 elements using A or P. So we print now element 2 from A and P. Now we try to change element A only, and we think that we copy the array, we change element A to 10, and we try to print again. What do you think the result will be? 10, 10. So here we are making the reference, we're not making the copy of the array, remember that, and the result will be 2, 2, because both of them are pointing to the same thing. Someone might think, oh, good, I did the copy correctly, but when you assign 10 to A, it's find out is also P have the same 10, because both A and P are accessing the same elements. We're not copying the element of array, we are adding another reference to that array. Is this example is clear for everyone? Good. Yes?
What would the same here change if you say B 2 equals to 10? Will still be 10 to 10 in the end?
No, it's if I make A is equal to P, in this case I'm going to have I'm losing A. Is now A and P pointing to an element that is not initialized at all.
Yeah, but if you keep B equals to A, but in the second to last line we'll say B 2 equals to 10, will still be 10 to 10 as it is now?
Yes, because both are the same thing. Even if I put P 10, 2 is equal to 100, I will see that also in A, because you have two names, A and P, are pointing to the same three elements. Okay. Now, to do the copy, this is the proper way. You have to do the for loop. Yes? If they are, you can do that. Because you always can change the reference. You can make the reference pointing to somebody, whatever. You can change the reference. Even if A and P are not the same length. You are just saying, you're playing with the reference. That's all. Now, you see here we have source array and we have a target array. And we define a source array. We initialize the value immediately. And also we define the target array as a new int, and we give the same length as the source array. This is the proper way of copying the element. In this way, we have a target array and source array are pointing to the different three elements, or in this case 5 elements are different. And we copy. This is the proper way of copying the array. This is an example to highlight this issue. We have here A and P. Both are defined and we initialize them both with 0. And in this case, we ask if P and A are equal. In this equal, what do you think we are looking for? Equality of content or equality of reference? Equality of reference, that's right. So we are checking on this equal, not about the content. And we can see here both P and A have their own content. And yes, the content are zeros. But both have this different reference, different memory on the address. So when I check A is equal to P, I will end up false because both have stored in different address on the memory. So this reference equality will end up with not equal. So equal. Okay, so this is, we'll check the address on this case. No, it's a problem. Okay. Okay, so then the result will be A is not equal to P. Now, you can, so you can see this method here, and if I told you what exactly this method is doing by just looking to it for half a minute and give me the conclusion. what this method is doing. So it's copying the element, that's what it's saying. So the name of the method is reverse. So trying to reverse the array, is that right? So we're trying to reverse the array, but I would like you to see also on the retain type how we can retain an array to the user. So in the retain type is int, and you have the square brackets, and the argument is int with the square brackets. And inside this method, the name is meaningful, it's reverse. It's taking the array and try to reverse it. And I create inside the method an array is called the result with the same length as the list array, which is the input array. I receive a list array, I create a new array. Then you see the I index. I index is a start from 0. This is a very compound for loops. So I is equal to 0 and comma j is equal to result minus 1. So we have two indices here, I and j. I is pointing to the 0 and j is pointing to the last element of result. Then I ask if I is less than list.length. If that's true, increment I and decrement j. And then we have result of j is equal to the list of I. So I'm retaining an array on reverse order. So if I have this input, array of list, and I have list 2 is equal reference list 1. This is, you can think about it, is another way of defining an array by receiving an output from the method. Here is the method will retain an array type, int of array type, because we create the array and we retain the result. This list 2 is already declared, and how much the size of it is inside the method is showing is list.length. Okay, any question about this? Yes. You can, if you can reduce the implementation is always different. I can use one index, okay? I can fix the length and sometimes subtract the length and increment the length, okay? But I use two index here. Now, this is a trace for the execution of the previous questions. I'm gonna go over it quickly. We ask if the list and then we start copying the element of the array. We have two index inside the for loop, so at each iteration we pick an element and we store it at length minus that element. So this is a slide to trace the executions. Any questions? It might be I ask you in the lab test, after executing this loop at loop iteration number 5, what is the result? Yes? No, you cannot. You cannot. Because otherwise, because you don't have an object, where are you going to do it? You need to create an array. You cannot do this without creating an array object. Otherwise, where are you going to do it? No, you cannot. We ask you to take this array and reverse it and retain another array. That is the question. Now, if I ask you to reverse the array on the same array, then that is different questions and different approach. If I ask you to take this array and make a reverse and retain. In this case, I will do the assignment here, list, and I have list 1 here, then finished. So both, then list 1 is, the original one is destroyed at all. Okay? Good. I can do this by just changing one this. But list 2, I make it list 1. Now, the original list is destroyed. Nobody can access the original one. You have the reverse one. Okay? Any question? This is the trace, reverse work. Let's say this reverse work, how this reverses work. Let's say you pick an element, I, in this case, is equal to 4. Yes? I is equal to 4. Then you ask, j is less than the result length minus 1? Yes. Okay. In this case, j is equal to 1. Yes. And then you ask, I is less than, here, I is less, no, j is equal to that, this is the initial statement, sorry. This I is less than the list length? Yes. In this case, 1, 2, 3, 4, 5, 6. So the 6 is element length. So 4 is less than 6. You increment I and you decrement j, but after the iteration. So the iteration is saying result of j. J is equal to 1. This is j. Will be equal to list of I. I is equal, in this case, is 4. 0, 1, 2, 3, 4. So 4 will be stored here. The next iteration, you will have I is equal to 5, and that is less than 6, okay? And you assign 5 to 0. In this case, j is equal to 0, okay? You can take this, implement it on the Android Studio, and see the execution. So you can see here at this slide, you have the list 1 is pointing to this element, and then you have a list 2 pointing to the same reference result, and result is pointing to this array. So you execute this reverse method and you retain 2 different arrays, okay? Now, the behavior of these 3 operations, assignment operations, could be the content for the primitive type. For a class, could be the address. For the arrays, the entire array is copying the address. The behavior is the same as the object. But if you have equal sign for the element, it depends if the element is a primitive data type or the object data type. For equality, if you want to check equal equal, that's compare the content of a primitive data type. If you have int equal to int, that's you compare the content of the value for int data type. If you compare with a class, you compare with the addressees, if they have the same address on the memory, so are referring to the same objects. The same thing for the array. And if the element depends on the element, if the element are a primitive data type or not a primitive data type. Now, for a parameter passing, if you are sending a primitive, you send the content. If you send the reference, a class, you send the reference to the array. You're not sending the element of the array. The same thing for the element of the array, again, for the reference of the array. So you can see the behavior of sign, equality, and also the parameter passing is different based on the data type that you are working with. So if you're working with an object and you send an object as an argument for the method, you're sending the reference of the object. You're not sending the content of the objects. Okay, testing 2 arrays for equality. If you would like to test 2 arrays, if they are equal or not, you have to go for each element inside this array and test if these elements are equal or not. Yes? Yes, we can have 2-dimensional array. We're going to come to that. It's another way of defining an array inside an array. So this is an example. We'll check that for equality. As you can see, the first thing we check if these 2 arrays have the same length. If 2 arrays have the same length, then this is a true. Then we're going to go iterations for each element. And we use the while loop to check if these elements are equal. And once we have not equal, we put the match false is equal to match, and we're going to exit from the while loop. You can do the for loop and use the break statement to exit from the for loop to implement for equality. Any question? Okay. Now we can see this problem. We have given this array, and we would like to do the average. Okay, so you can see the array is number, and we have to go through this array and find the average. So we define sum is equal to 0, and we have the for loop, I is equal to 0, I less than number dot length, I plus plus, then we add the element of array to the summation. And you can see this is an increment summation, sum plus equal is number dot I. Then after we finish the loop, we have the sum of all the elements. Then we do the averaging. The elements are integers and the average is double. So we have to do the casting to make sure this is double divisions, not integer divisions. So we do the casting for doubles and we print the average. This is another way. You can see we throw an exception in this case. Another implementations. An implementation, if the array dot length is equal to 0, we throw an exceptions. Throw a new exceptions that this array has a 0 length, and you're trying to make an average of array of length 0, which means you have a null pointers and you're trying to calculate the average one. Otherwise, if we are not throwing the exception, we're going to go back here and we calculate the average. So it's depend on the developer who are going to implement the method and make his implementation more robust. Okay. Now, in the first implementation, it doesn't matter for you if you have an array of length 0 or not. You're going to try to execute and you're going to run with an exception, runtime exception. You might not know about it. But in this case, if I raise an exception, I will have the meaningful message saying the array with a length 0. Now, given this problem, I need to print the content on the backward. So how I can approach this problem? I have the array, so I have to go for loop for all the elements in the reverse directions. I know that once I define the array length is fixed. So I use that information. So I use I as a number dot length minus 1, and as long as I is greater than or equal to 0, I will keep decrementing I. Then I keep in each loop is printing the element at I. Now I have this problem. Given an array of numbers, if it contains all positive numbers. So I'm trying to see if this array contains only a positive number. So again, I'm going to use for loops to check all the elements. Or might be I use while loop. I can use for loop and break once I have a negative numbers and keep checking. Once I see a negative number, I break out. Or I can do the same thing with I did for equality. I use for loop, while loop, and I use the status as a part of the conditions. Let us see here. We have numbers and we have Boolean defined. So far, only positive number is equal to true. I is equal to 0. And then we have I, while loop, I is less than the length. And we ask, so far, positive numbers equal, so far, and with the number at I is greater than 0. And we increment I at each iteration. And then after the while loop, after I check all the elements, okay? After I check all the elements, I ask if so far is positive, then I'm going to print all the elements are positive. Otherwise, at least one of them is negatives. Any questions about this implementation? Okay. Now, I would like you to see the difference, sense the difference between the first implementation and the second implementations. So in the first implementations, I have to go to visit all the elements. I cannot finish early once I see a negative element. I have to visit all of them. And imagine if you have 1 million elements. So it will be time consuming to visit all of them. Is that right? But look at the second implementation. There's nothing changed with the first one to the second one, except we are using so far only as a part of the conditions. So if so far only positive numbers is false, immediately we're going to stop execution and we print to the user at least one negative element we found. You see that? So that is different on the implementations. Give you an indication how much you are efficient. Okay? of using the computation resources. So in the first implementation, regardless if you find the negative element at the first at index is equal to 0, you have to visit all of them. But in the second implementation, no, that's not true. Once I found a negative element, I will immediately exit from the loop. Okay? I can do this with a for loop with a break statement. So if the condition this is violate, I break, I will exit from the for loop. Any question? Okay, so we have given an array of integers. How to determine if it's sorted in non-descending orders? So given an array 1, 2, 4, return true. Given 2, 4, 3, 3, return false. So it's sorted in ascending order from the smallest to the largest. Descending order from the largest to the smallest. So we need to make sure this array is sorted. When I say it's non-descending order, that's meaning in ascending orders. How we can do that? Okay, we can do the comparison, or we can visit them one by one, and whenever we are sitting on the element, we look at the next element if it's greater than this element. Okay? So you can see here we have the array and we define is sorted, and we say I is equal to 0, and inside the for loop we have this compound conditions is sorted and I less than a dot length minus 1. Why I do this? Why I choose a dot length minus 1? I need your answer later on. Then I have I plus plus. Inside the body of for loop, I have this statement. Is sorted is a Boolean variable is equal a at position I less than a at position I plus 1. If this Boolean expression is true, we're going to go back to the next iteration. Otherwise, we're going to go out. You can see now how we implement the for loop, so we're not visiting on the element. Why we have here a dot length? Normally we have I less than a dot length, not a dot length minus 1. Any answer? Yes? Exactly. So we did our task to prevent an exception to be raised out of bound. Okay, exception. So if I keep a dot length, imagine if I is equal to, let's say this array 1, 2, 3, 4. If I is equal to 3, a of 3 is exist, but a of I plus 1, a of 4 is not exist. So we will have a runtime exception. That's why I make sure that I have length minus 1. Now, what is the two-dimension array? We have ability to create a two-dimension array on the Java. So we have to define now not only one square brackets, we have to use double square brackets. Okay? So you can see here int square brackets, open and close, then table equal a new int, and we give the length. 10 rows, and each row has 6 columns. Okay? How this? So multi-dimension array is, we can do it on the Java, but we have to make sure that we are following the syntax. Look here, we have tables, and we have 3 rows and 4 columns. So this is a one-dimension array of 3. You can think about it, and I have dimensions, 1 dimension of array, 3, and each element on that is another array of a dimensions of 4. That is back to your questions. I can have an element where inside the array, element is another array. This is the same thing. So you can think here we have 3 elements. Inside each element is another array. So we have 0 elements, table 0, and the length of that element is 4. This is exactly the same. You have 0, 1, 2, 0, 1, 2, the 3 elements, and you have 0, 1, 2, 3 is an element. You can think about, visualize it as this. This is the table 0. If you put table 0, this will retain an array of length 4. If you put table 0 and then you open the bracket and close the bracket and you put 1, this will retain element of 0, 1. So the table.length, if you ask like this, table.length will retain 3, because table is referring to the array of 3 elements. If you say table dot open the bracket with 0, dot length will retain the row length, which is the number of columns. So it's very important to keep this in your mind. Whenever you're dealing with two-dimensional array, table.length will retain what? The length of the array, the length of number of rows. Now, if you need the number of element in the column, you say table 0 and you ask for the number of columns. This is an example of defining an array of 5 by 5. So int, you open the brackets, 5, close it, open the bracket 5 and close it. This will retain array, two-dimensional array of 5 by 5. Now, can I define and initialize the array when I create it? Yes, I can do that. I open the braces, but for each one, I put the braces. So, because each one of these is an array. So this is the first element, 1, 2, 3, 1, 2, 3. Then 4, 5, 6, 4, 5, 6. Then 7, 8. This is the third row, 7, 8. And 10, 11, 12, that's the last row. And don't forget the semicolon. So there's a braces, the big one for the table. And then you have individual braces for each row. This is how we access the array of 2 dimensions. 2-dimensional array is the same as 1 dimension. You have to provide the index. Indexes start from 0. So the first element of this table of 3 by 4, it's x00, 0. That is the first element. Then x01, x02, x03. Now, x of 0 dot length will retain 4 as 4 elements. Okay? Now, you can see this example. You can have a 2-dimensional array with different sizes. Oh, that's amazing. Okay? So you can have an array with have different dimensions. So you can see here is not only symmetric 5 by 5 or 3 by 4 or something. You can see here the first element is array of 5 elements. Here is 4 element, 3, and this is 1 element. Okay, so you can do that on Java. I can have an array, 2-dimensional array, whereas the column I have a different size. Now, if I want to change one element, I can access the second row, and this is second row or third row. Third row, because indexes start from 0. Third row, second column. Third row, second column, I have changed the value. I assign the value similar to the 1 dimension. Now, rigid array is when you have a row of 2-dimensional array of different length, as I mentioned, is called rigid array. You can see here, I can have this. I define 2-dimensional array. I define the number of rows. That's all. I did not define the number of columns for each row. Then I go for each column, I define them later on. And you can see here I have 4 rows and 3 columns in the first row. In the second row, I have 4 elements, 4 columns. So you can do this on Java. So you can have an array of different columns. I can declare an array and I give the number of rows at the beginning, as you can see on the slide, and then later on I decide how many elements in each row. This is a problem. We have 2-dimensional array of integers and we need to calculate the average of them. How we can do this? So in this case, we have to visit all the rows and all the columns. To be able to do this, we can use nested for loops. So as you can see here, we define this array of two-dimension array. We have 2 rows, and how many columns we have? 4 columns. So we start with total is equal to 0, number of element is equal to 0, and what we do here, we start by visiting each row, and we ask a.length. Always a.length will retain number of rows, and then for each row we have to ask individually about the length. It happens sometimes it's symmetric, that all the rows have the same length, but we have always to ask for the length. So we can see this is the outer for loops, is to visit all the rows, and this is the inner for loops to visit all the columns, and we ask a, and we open the brackets and we ask row, and in this case row is 0.length, and we increment the column and we add the element to the total rows and columns, and that we also increment the number of element. Why we need the number of element? Because we need to calculate the average. We need to calculate the average. So we need the number of element. At the end here, we calculate the average and send it back. Any questions? Yes. Yes, because Java allowed the user to define an array where the length for each row is different. You cannot assume that the client make the length for each row is the same. So that's why in the second for loop, we have to check for the length for each rows. Yes? You can. Yeah, you can do it nested. You can have 2 array, whereas inside the 2 array is dependent. You can have multi-dimensional array, but we are discussing 2 dimensions in this class. Okay? Now, we need to find the maximum and the minimum. We have 2-dimensional array. We need to find the minimum and the maximum of the array. So we go visit all the element of the array, and we try to find the maximum and the minimum for each array. So you can see here we define the maximum and the minimum to be the same element at the 0 element, and then we ask if the element of the array is greater than the maximum, we define the maximum, we redefine it again. If the element is less than the minimum, we reassign the minimum. This is how we determine the minimum and the maximum for each array. Okay? 2-dimensional array. And you can see we have again nested for loops. And remember, a.length will retain the number of rows. Any question? Okay. These are problems. You can take it at home. You can see how you can find the maximum sum. Find out the row which has the maximum sum, and also you need to determine if all elements are positive. That's second problem. The third problem, you have the 2-dimensional array A, and determine if it's rectangle. What I mean that the number of rows and the number of columns for each row is the same. The number of columns, each row has the same number of columns. Okay? Any question? If the number of columns is equal to the number of rows, that's square matrix. If the number of columns in each row is the same, this will be a rectangle matrix. Okay? Any question? Now we start a string. It's good to recognize that a string and characters are both totally different. So let us establish the difference between the string and character before we dig deep. So in Java, whenever you need to define a characters, we know that there is a wrapping class called characters, and there is a primitive data type called char. Now, a primitive data type is declared with single quotation. Here is char ch1 is equal to x. So by doing this, we are declaring a single characters. This is not a string. This is just a single character, a primitive data type. In Java, we use a Unicode word-wide character, which is Unicode abbreviated, that is support storing and processing these characters that we store. Now, so whenever are using a char as a character, Java will take this character and translate it to a number. And this number is Unicode word characters standard. There is a lot of methods that can help us to handle these characters. One of them is asking if this character is digit. We can ask if this character is digit. What do we mean by digits? We mean that if this character is really a number digit between 0 and 9. We can ask if this character is a letter. We mean by A capital or small capital, B, C up to Z. Is a character is a letter or a digit? That means it's A up to Z, 0, 9, there is no spaces, no special characters, no backspaces, no tabs. So we ask if the character is a letter or a digit. Also, we can ask if this character is in lowercase, uppercase, okay, and it's a white space characters, space or tab, and we ask if it's two lowers, so we can convert the characters to a lowercase and to upper to change the status. We retain another character. As you can see, we retain a characters. So we take a characters, we retain the lowercase equivalent for this, and we retain a characters. As you can see, all these methods are static methods and public method. So you can use them without creating an object of the class. We can do arithmetic for the characters. So if we have A capital plus 1, Java will convert A capital to a number, which is 65, and then add 1 to 65. That will make it 66. And then look at the Unicode and see 66 is equivalent to P capital. So this is how we can do the character arithmetic. So yes, we have A as a character plus 1. We say that we need P capitals. We can generate a random characters. So we can ask the random number that we discussed in the previous lectures to generate a next integer between A capital and small, A capital and Z capital. So it will retain a integer number between A capital and Z capital. And this number that we have, we can cast it back to characters. So in this case, we generate a random characters, okay, for the user. So you can ask to generate a random message in your app for chapter number 4 to generate a random note, and then this random note encrypted or decrypted, or you can put your node. Now, I can ask if the character is a digit, so I re-implement this by saying if the character is greater than 0 or less than 9 as a character, not as a value. So whenever it's come across comparing the character value, we can use greater than, equal, less than or equal, because we are comparing a primitive type. And we understand now, Java understands character as an integer. So integer is a primitive type too. So we're not afraid of using if A capital less than P capital, or A small less than P small, because these are a primitive data type, and Java will understand these characters as a Unicode. And once the Java understands it as a Unicode, we can say if a Q capital not equal to Q small. So we don't need to use dot equals method with a character, because character is a primitive data type. Now, we can do for loops as we do it with an integer type. We can have a char C is equal to A, semicolon, C less than Z small, C++, and in this case we're printing all the alphabetic from A to Z small. So, no, I said Java understands character as a Unicode, and Unicode will be an integer value. Yes. Yes. You have to cast it. Yes, like this one. Yes, you see this one? A random number generate an integer value between A capital and Z capital. This will retain an integer value. Now, Java will understand it as an integer value. I have to let the Java understand this is character. So that's why I have to cast it. You can cast int to char. Yes. So when I say char is a characters, primitive data types. Okay? You can see this for loop will print all the alphabetic from A small up to Z small. Now this is an exercise where we have to implement a method to hex digits. So what is the hex digits? So if the argument is between 0 and 9, we're going to retain 0 and 9, but we retain what? A character, okay, with single code. That's the hex code. If the argument is between 10 and 15, we have argument integer between 10 and 15, we retain A up to F. So A, P, C, D, E, F. F represents 15. If the argument is outside, we're going to retain a question mark. So we're going to implement this method. That is what is required for us. We're going to receive an integer. If the integer is between 0 and 9, we're going to retain the corresponding characters. If the integer's value between 10 and 15, we're going to retain A for 10, P for 11, C for 12, and F for 15. We start, we receive an integer, and we retain a character, as you can see. Public, character as a retained type, the name of the method is given to us, and int as an argument. If the integer is greater than or equal to 0 and less than or equal to 9, in this case, we're going to retain what? The character. So we take the retain and we do the arithmetic for the character. We take n plus the Unicode of 0. So by putting this, we're going to have the Unicode that represents the 0, and we add n to it. So the Unicode of 0 plus 0 will retain Unicode of 0. Unicode of 0 plus 1 will retain a Unicode of 1. So by this, we retain a character between 0 and 9. We have else if statements if the character is greater than or equal to 10 and less than or equal to 15. So in this case, we're going to take the A, a Unicode of A, and we're going to add 1 to A, or 0 to A, 3 to A, up to 5 to A. Once we add 5 to A, we retain F capital. We're doing character arithmetics, okay? We start understand the current characters as Unicode, and we add, we subtract from the Unicode. Else, we retain the question mark. So we implement in this method, we implement the integers to hex, okay, which is the hex representations for the computers.
What's the purpose of returning 0 plus F?
Because we have to retain a characters. We cannot retain integers. So when we have the Unicode of 0, we add 1 to it, then we retain a Unicode for the character of 1.
So you can't just say N and cast it to character.
No, because N will be 1. And you cast it to integer, you will not retain the value. Because 1, you will retain different characters. Try it at home. Try to see this one and put N without adding a Unicode of 0, because you have 1 byte to define all the characters. So number 1, when N is equal to 1 and you cast it to characters, you will look at the table of Unicode. 1 will be different characters, okay? But to be able to retain the right character, you have to add the offset here, which is the character Unicode of 0, and in this case, the Unicode for A capitals, okay? Try to see this code in your machine and try to manipulate and see what's the difference, why we add this here and why we add this here, okay? Any question? Okay, so we stop at the string and we continue next week.